This is section 10.6, secants, tangents, and angle measures. Skim the lesson, write 2 things you already know about secants, tangents, and angle measures. Well, we could write our equation. We know that the angle is half of the arc. We know that a tangent touches the circle. I guess you could put for the top one, that's for an inscribed angle. But what you have written may be a little bit different than what I put. So determine the measure of each angle in the diagram and justify your answers. So this is review back from not lesson 1.5, all the way back from chapter 1. It started in the very beginning of chapter 1 and then continued throughout that chapter, but we've used it all semester and all year long, really. I would look at angle 1 and the angle that's 125 and notice that they are going to be supplementary. I could say 180 minus 125 is going to give me the measure of angle 1, which gives me the measure of angle 1 is 55. I can look at angle 2 and notice that 125 and angle 2 are vertical. So angle 2 is also going to be 125 degrees. And I could say that's because it's vertical and vertical angles are equal. If I use that same logic, I could say angle 3 is going to be 55 degrees because it's vertical to angle 1. We can be a little more specific here. Okay, so you can solve for all 3 of those missing angles given just one. Write the definition next to the term. So secant is a new term that we were given in this section, and a secant is a line which intersects a circle in exactly 2 points. So I remember the difference between secant and a tangent. Tangent touches and a secant slices. So it's going to go straight through the circle. If this is my circle, my secant is going to intersect not at just one spot, but in 2 different spots. So it goes all the way through so that it can intersect in 2 places. Find the value of x. Show your work in each box as indicated. Determine the measure of angle EAF. So that would be right here. Well, the issue is that that's the inside angle and I'm given both of the arcs. So I notice that my 2 intercepted arcs are EF, which is 136, and HC, which is 62. So I can find the measure of angle EAF by adding those up and dividing by 2 or multiplying by a half. I find that it's 99. If this portion is 99, then I can find the measure of CAF, which is the same as x, because these 2 angles, let's see if this is going to go. There we go, are supplementary. They're on the same line. So I can say 180 minus 99 will give me my angle x of 81. So when I had given you the equations before, we had that when our vertex was outside, something like this, that's on. Let me fix that. Still not great. There we go. We would take these 2 arcs, this one and this one, and we would subtract and multiply by a half. So we would say 1/2 arc minus arc. But this time, when we're inside, we're going to add. So I think of this as you want to be inside the circle, you don't want to be outside the circle. Being outside the circle, like with friends or with anything, makes you feel bad, it's sad, it's subtraction. Being inside the circle in your group of friends is good, it's addition. So I gave you a little more information that you needed really in a couple sections ago. So we're going to kind of go over these situations here. But let's label each of these parts. It says label each diagram and explain how you would determine the measure of angle 1 in each diagram. So this first one right here, this would be the intercepted arc. This line right here only touches the circle in one point. I would say that's the tangent. And this last one right here, it goes straight through. This is the secant. Well, I notice the vertex of my angle is on my circle. So if you remember from notes a few days ago, I said the measure of something where the vertex is on the circle is 1/2 the measure of the arc. So if I had my arc was 100, that means that my angle is going to be 50. It's going to be half of that. Now in this case, I have not just one intercepted arc, but I have two. Okay, given those two, I also not only have one secant, but I have two. It's going through both at two different places. I notice that my vertex here is outside. And like I said before, outside we're thinking is bad. So now I'm going to do 1/2 times the arc minus the arc. And we're talking about real measures. So how do you know which order to subtract? Well, you can't have an angle measure in this case that's negative. We're only looking for positive values. Therefore, you need to subtract the bigger arc from the smaller arc. So the bottom part just says helping you remember. How do you remember the difference between secant and tangent? We can write it down again. A secant slices, it's cutting it in two places, and a tangent touches, it's only touching the circle at one place. So that's how I remember the difference for those. So again, like I said, I gave you way more information than you needed a couple days ago, so this may seem a little bit like review, but we have three different situations. We have one where the vertex is inside, one where the vertex is on, and the last one where the vertex is outside. So we're not just looking at central angles at this point, we're looking at angles that are either in the middle of the circle somewhere, on the edge of the circle, or outside of the circle. So that's all for 10.6. Make sure to do your assignment and we will